What if I told you that the deeper you go into space, the stranger reality becomes? Out there, time slows down, the human mind begins to hallucinate, and even the laws of physics start to twist. Deep space isn't just a dark, empty void. It's a place full of mysteries that can change the body, the mind, and even our understanding of time itself. In this video, we'll explore the weird and unsettling things that begin to happen when humans travel into the unknown. When we think about time, we imagine it moving forward at the same speed for everyone. 1 second here on Earth feels the same as 1 second anywhere else. But in deep space, time doesn't always behave the way we expect. According to Einstein's theory of relativity, time is not fixed. It can stretch or slow down depending on how fast you're moving or how close you are to something with a huge amount of gravity, like a black hole. This means if you travel through deep space at very high speeds, close to the speed of light, time will pass more slowly for you compared to people who stay behind on Earth. For example, you could spend what feels like a few years on a journey, but when you come back, decades or even centuries might have passed on Earth. To you, only a short time went by, but to everyone else, the world has moved far ahead without you. This effect isn't just science fiction. It's a real scientific prediction proven by experiments with satellites and fast-moving particles. It may sound unbelievable, but in deep space, the faster you travel, the more time itself bends around you. When people imagine space travel, they usually think about rockets, stars, and planets. But what we don't often think about is what happens inside the mind when a person is far away from Earth, surrounded by nothing but darkness and silence. Deep space is not just empty, it is also extremely lonely. And this loneliness can play strange tricks on the human brain. On Earth, our senses are always busy. We hear sounds, see people, touch things, and live in an environment full of life and movement. In space, especially in deep space, most of that disappears. Astronauts describe it as being in a world where nothing changes. There are no trees moving in the wind, no birds, no voices, and sometimes no sign of anything at all. It is just you, the spacecraft, and an endless black sky. This kind of environment can lead to sensory deprivation, where the brain starts craving input. When it doesn't get enough, it begins to create its own. That is why some astronauts report seeing strange lights or hearing odd sounds even when nothing is there. These are hallucinations, false signals created by the brain to fill the silence. But it's not just hallucinations. The human mind also struggles with the idea of being so far from home. Imagine being millions of kilometers away from Earth, knowing that if something goes wrong, there is no quick way back. This constant pressure can cause anxiety, stress, and even depression. Some researchers compare it to being trapped in isolation for months or years. NASA has studied these effects during long missions on the International Space Station. Even there, where astronauts are only a few hundred kilometers above Earth, they sometimes report mood changes, sleep problems, and moments of confusion. Now imagine those effects magnified in deep space, where the isolation is far more intense and the mission could last years instead of months. Psychologists believe that in deep space, the human brain might start creating illusions not just out of boredom, but as a way to protect itself. The mind could blur the line between reality and imagination, just to give the person something familiar and comforting. But of course, this can also be dangerous, because an astronaut might react to something that doesn't actually exist. In the end, deep space is not only a test of technology, it's also a test of the human mind. Our brains evolved on Earth, surrounded by people, nature, and activity. Taking that same brain and placing it in the silent infinity of space changes how it works in ways we're only beginning to understand. When we live on Earth, we don't often think about radiation. Our planet protects us from most of it with a thick atmosphere and a strong magnetic field. These invisible shields block harmful rays coming from the sun and from space. But once you leave Earth and travel into deep space, those shields disappear. Out there, radiation becomes one of the biggest dangers humans face. Radiation in space mostly comes from two sources: the sun, and distant cosmic rays. The sun gives off powerful bursts of energy, especially during solar flares. These blasts can release streams of charged particles that move across the solar system. On Earth, they may cause colorful auroras near the poles. But in space, without protection, they can be deadly. Cosmic rays are even stranger. They don't come from our sun, but from exploding stars and other violent events far away in the universe. These particles travel at nearly the speed of light, carrying huge amounts of energy. When they hit the human body, they can damage cells, DNA, and organs. Over time, this can increase the risk of cancer, weaken the immune system, and even cause long-term changes in the body. Astronauts who have been outside Earth's protection sometimes report something unusual, flashes of light, even with their eyes closed. These flashes are caused by cosmic rays striking the retina or brain. Imagine sitting in total darkness, then suddenly seeing bursts of light that don't exist outside of your mind. It's one of the many strange reminders that space is never truly empty. It's full of invisible energy passing through you. On Earth, we have walls, roofs, and protective gear that block radiation. But in deep space, building that kind of shield is much harder. Spacecraft can only carry limited protection because thick shielding makes them too heavy. Scientists are still searching for better ways to protect astronauts on long journeys, like to Mars or beyond. The danger of radiation is one of the main reasons humans haven't traveled too far from Earth yet. A trip to deep space could last years, and constant exposure to cosmic radiation could harm the crew before they even reach their destination. Some researchers are exploring whether water, magnetic fields, or even new materials could serve as shields in future spacecraft. Radiation reminds us that deep space is not just about distance. It is about survival. Without Earth's natural defenses, humans are directly exposed to the raw power of the universe. It is a silent enemy, invisible and unstoppable, always waiting in the background. When we use our phones or computers here on Earth, communication feels instant. A message travels from one person to another in just seconds. Even astronauts on the International Space Station can talk to Earth almost in real time. But once you move farther into deep space, that changes. Communication no longer feels instant. It slows down, sometimes by minutes, sometimes even by hours. The reason is simple. Signals cannot move faster than the speed of light. When you send a message from a spacecraft, it has to travel as a radio wave all the way to Earth. The farther you are, the longer it takes. For example, if you were on the moon, your message would take about 1.3 seconds to reach Earth. That's not too bad. But if you were on Mars, depending on where the planets are, it could take anywhere from 5 to 20 minutes. Imagine asking a question and waiting almost half an hour for an answer. Now, picture traveling beyond Mars, into the deeper parts of the solar system. At those distances, a signal could take hours just to get back to Earth. If something went wrong on your spacecraft, you wouldn't be able to get quick instructions or help. By the time Mission Control received your message and sent back advice, the situation could already be very different. This delay changes how missions are planned. Instead of depending on Earth for constant support, astronauts would need to solve problems on their own. They would need more independence, stronger training, and smart systems on the spacecraft to guide them. Communication delays don't just affect safety. They also affect how astronauts feel. Being far away and waiting a long time for replies can make them feel even more isolated. On Earth, we're used to sharing things instantly with family and friends. But in deep space, a simple conversation could feel like writing letters in the old days, where you send a message and wait a long time before hearing back. NASA and other space agencies are working on ways to reduce these challenges. They're testing artificial intelligence systems that could give astronauts immediate answers when Earth is too far away. They're also planning for new communication technologies, like laser-based systems, that can send data faster and more reliably than radio waves. Still, the speed of light itself is a limit we cannot break. No matter how advanced our technology becomes, if you're in deep space, you'll never be able to talk to Earth instantly. That's one of the strangest parts of leaving our home planet. Distance doesn't just separate us physically, it also separates us in time. On Earth, the laws of physics feel familiar. We drop something and it falls. We breathe air, and our bodies respond the way they always do. But once you enter deep space, things don't behave in the same way anymore. The rules of reality feel different. One of the biggest changes is gravity, or rather, the lack of it. In deep space, far away from planets or stars, you experience microgravity. This means your body is basically weightless. At first, it might sound fun, floating around like a balloon. But over time, microgravity has serious effects on the human body. Muscles weaken because they no longer carry your weight. Bones lose calcium and become fragile because they don't need to support you. Even the heart can shrink slightly, since it doesn't have to pump blood upward against gravity. Your sense of balance also changes. On Earth, the inner ear helps us know what is up and down. In space, without gravity pulling in one direction, the brain gets confused. Astronauts sometimes feel disoriented, dizzy, or even sick until their bodies adjust. Imagine waking up and not being able to tell which way is up, because in truth, there's no up or down. But it's not only biology. Physics itself acts strange in deep space. For example, fluids don't flow the way they do on Earth. Instead of pouring, water forms into floating spheres that drift through the air. Fire burns differently too. On Earth, flames stretch upward because hot air rises. In microgravity, fire forms into a small, glowing ball. Even something as simple as cooking food or drinking water becomes a whole new challenge. Then there are the mysteries of the universe itself. Space is full of phenomena that bend the rules we thought were fixed. Black holes can warp space and time, bending light like it's made of rubber. Neutron stars spin so fast and emit such strong forces that they seem to defy imagination. Even quantum effects, which already sound strange on Earth, may behave in new and puzzling ways in the emptiness of space. And let's not forget the overview effect. This is not a physical law, but a psychological shift many astronauts experience. When they look down at Earth from space, they see the entire planet as one small, fragile sphere floating in darkness. Borders disappear, divisions fade, and everything looks connected. Many astronauts describe it as life-changing, like seeing the world for the very first time. So, in deep space, physics is not just a subject from textbooks. It becomes a living, changing experience. Gravity, balance, fluids, fire, even our view of reality itself. They all feel different, reminding us that Earth is only a small corner of the universe where things behave the way we're used to. Step outside that corner, and the rules begin to shift. When we look at all the strange things that happen in deep space, time slowing down, the mind playing tricks, invisible radiation, delayed communication, and even the laws of physics feeling different, it all leads us to a bigger, deeper question. What would really happen if humans left the solar system and traveled into the unknown? The truth is, we don't fully know. Deep space is filled with mysteries we haven't solved yet. For example, what is dark matter? The invisible substance that makes up most of the universe, but cannot be seen or touched. What about dark energy, which scientists believe is pushing the universe to expand faster and faster? These forces are everywhere in space, but we don't understand how they might affect us if we travel farther than we've ever gone. Then there's the question of time itself. If time can bend near massive objects, what would happen if humans traveled close to a black hole, or even through one? Would we survive the journey? Would time stretch so much that we could see centuries of history pass by in what felt like a single hour? Or would we vanish into a place where the laws of physics simply stop working? Another mystery is whether deep space is truly empty. Our instruments detect strange signals and unexplained bursts of energy from distant galaxies. Are these natural cosmic events, or could they be signs of something we don't yet understand? Some scientists believe we might one day find evidence of other civilizations, not by meeting them directly, but by noticing their fingerprints in the universe, signals, structures, or patterns we cannot explain. The farther we go into space, the less certain everything becomes. It's like stepping off the edge of a map into an ocean with no landmarks. Each answer we find only raises more questions. Deep space challenges not just our technology, but our understanding of reality itself. And maybe that's the ultimate mystery, that the universe is far stranger than we can imagine. By leaving Earth, we are not just exploring space. We are exploring the limits of human knowledge. The more we go forward, the more we realize how small we are and how much there is still left to discover. So, what really happens when you go into deep space? Time doesn't flow the way we expect. The human mind begins to see and hear things that aren't there. Invisible radiation quietly threatens the body. Communication with Earth slows to minutes or even hours. Physics itself seems to bend, and the deeper we go, the more mysteries appear. Deep space isn't just a journey across distance. It's a journey into the unknown. It changes the body, the mind, and even our understanding of reality. And while we've learned so much from science and from the astronauts who've traveled beyond Earth, the truth is that we've only just begun to scratch the surface. One day, humans will leave the safety of our planet and travel farther than ever before. Maybe we'll settle on Mars. Maybe we'll cross the solar system. And maybe one day we'll step beyond it. When that happens, the strange and mysterious effects of deep space will become part of everyday life for the explorers who dare to go. But until then, all we can do is wonder. What secrets does the universe still hide? What strange things will we discover when we finally go deeper than anyone has gone before? Now I'll leave the question to you. What do you think is the weirdest thing that could happen to humans in deep space? Share your thoughts in the comments. I'd love to hear your ideas.